All right, let's dive into one of the absolute weirdest ideas in all of science. It's a proven fact, and it's going to completely mess with how you think reality works.
No, I mean, seriously, just think about that for a second. What if just looking at something didn't just, record what happened, but actually created what happened? Sounds like something out of a movie, doesn't it?
Well, it's not. Down at the tiniest levels of our universe, this is a proven fact. We've seen it in experiments. So yeah, welcome to the totally mind-bending world of the observer effect.
Okay, so to really get how bizarre this is, let's first talk about the world we actually live in, the one that makes sense, the world of normal everyday physics.
Think about it. If I throw a baseball, you can watch it fly through the air, right? You can measure its speed, figure out its arc, and your looking at it doesn't change a single thing about its path. It's predictable, it's reliable, it just makes sense.
But when we zoom way down to the level of electrons and photons, all those common sense rules, they just get tossed right out the window. Down there, things get seriously weird.
So in this strange new quantum territory, there's a new rule book. And rule number 1, it completely changes the game when it comes to the relationship between an observer and the thing being observed.
And this right here is the absolute heart of it all. See, in the quantum world, you can't just be a passive observer. The very act of measuring a particle, even just to figure out where it is, actually messes with it. It forces it to act in a totally different way than it would have if you hadn't looked. And I gotta stress this. This is not some philosophical debate. It's a real-world thing that's been proven again and again and again in labs all over the world. So how on earth did they prove something so crazy? Well, that brings us to maybe the most famous and, honestly, the most baffling experiment in the history of physics. We're talking about the double-slit experiment. It shows this whole weird rule in action, perfectly. Okay, so the setup seems super simple. Imagine this. You've got a little cannon that shoots out electrons, just one at a time. In front of that, there's a barrier with 2 tiny vertical slits in it. And then behind that, you've got a screen that lights up wherever an electron hits. Easy enough, right? All right, scenario 1. We're just going to fire the electrons and let them do their thing. Super important, we're not watching which slit they go through. No detectors, no peeking. And this is where your brain starts to melt a little. Even though we're shooting them one by one, they stop acting like little tiny bullets. Instead, each electron starts acting like a wave. It spreads out and somehow it goes through both slits at the exact same time. And the pattern that shows up on the screen behind it, it's the proof. You don't get 2 neat lines like you would if you were just shooting pellets. No, you get this wild pattern with lots of bands. That's called an interference pattern, and it's what happens when waves crush into each other. It means the electron literally interfered with itself. Okay, that's already weird enough to think about. But this is where things go completely off the rails. The scientists, they got curious. They thought, we gotta see this. We wanna know which slit each electron really goes through. So that leads us to the big, universe-breaking question. What happens if we just peek? What if we stick a little detector right there at the slits to watch which path the electron takes? Okay, scenario 2. We run the exact same experiment, but with one teeny tiny change. We put a little measuring device right at the slits, ready to catch the electron in the act. And the second we do that, everything changes. The electron's behavior just flips. It's almost like it knows it's being watched. It drops the whole wave thing, it chooses one slit to go through, and it acts exactly like a predictable little solid particle. And the results on the screen, the interference pattern, poof, gone, vanished. All that's left are 2 simple bands, exactly what you'd expect if you were just shooting tiny little bullets through 2 slits. The weirdness is just gone. Okay, let's just put this side by side because this is the whole shebang right here. When we're not looking, it's a wave, it's this cloud of possibilities. The moment we look, bam, it's a particle, a single, definite thing. The only thing that changed between these 2 realities was the act of watching. So naturally, this just rips open a Pandora's box of huge, deeply unsettling questions about, well, everything. The universe, our place in it, what's even real. This really gets to the core of it all. What it means is,
Down at the quantum level, you can't ever be a separate observer. The act of measuring isn't just looking at what's there, it's part of the process that determines what's there. The observer is always part of the experiment.
And, this sparks a huge debate. Is it about consciousness? Does a human mind have to be involved? Or is it just about the physical act of measurement itself? Bouncing a photon off an electron to see it. Nobody knows for sure. What do you think? Does consciousness change reality, or is it just physics? Drop your take in the comments.
What this suggests is something truly profound. That at its very core, reality isn't solid. It's just a shimmering cloud of possibilities, a haze of maybes, until an observation, an interaction forces it to snap into one single definite state. And that leaves us with a question that scientists and philosophers are still wrestling with today. It's a heavy one. If you want to keep digging into these kinds of reality-bending questions with us, make sure you subscribe for more deep dives into the wonderfully weird world of science.